Good morning. So we're going to go ahead and, if you saw the agenda for this morning, you guys have to, I asked that you guys complete practice number 4 and submit page 701, 702, which is numbers 1 through 8. And it just talks about the power of the discriminant and the nature of the roots, if any, exist. So the notes part now is coming back to the quadratic formula, but now putting it all together. So, for example, number 1, solve the following equations using the quadratic formula. So what I'm going to do first is step 1. We're going to revisit the nature of the discriminant. So step 1, we're going to go b squared minus 4ac. So we've got b squared minus 4 times a times c. And now I'm going to just drop in those numbers. So b is 3, a is 1, and c is a negative 2. So I know that 3 squared is 9. And then I look at this as one whole product, and there's 2 negatives there, which makes this whole thing positive. And then 4 times 1 is 4, times 2 is 8. So with that said, 9 plus 8 is a positive 17. Okay. So with that said, because it's positive, that means that 2 real roots exist. So I'm going to go solve for those 2 real roots because this is the idea of the quadratic formula, is to find the x-intercepts. All right, so because this is my discriminant, I'm now going to plug it into that fun formula. So here we go. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. But the nice part is that we already solved for the b squared minus 4ac under the square root. So we don't have to redo that. So x equals a negative times b plus or minus the square root of b squared minus 4ac, which we already found to be 17. So I'm not going to rework that. All over 2 times a. So now I'm going to go plug in the numbers. So b is 3. We already found the b squared minus 4ac to be 17. And then your a value is 1. So now I'm going to simplify this as much as I can. So I get x equals negative 3 plus or minus the square root of 17 all over 2. Now, that means that I have a root at negative 3 plus the square root of 17 all over 2 and a negative 3 minus the square root of 17 all over 2. So those are my 2 x-intercepts. Now, keep in mind, we're always going to look to see if we could simplify here or here. And in this case, we can't. So this is our final answer for our 2 x-intercepts. All right, let's try another one. All right. Again, before you use the quadratic formula, you have to make sure that the equation is equal to 0. So with that said, before you take a, b, and c. So with that, I'm going to go ahead and move this to the left side and set it equal to 0. So negative 3w squared minus 7w plus 2 equals 0. I had to add 2 to both sides in order to get it equal to 0. And now I can go ahead and start with step 1, finding my discriminant. So step 1 is going to be b squared minus 4 times a times c. So b is a negative 7, a is a negative 3, and c is 2. So now I could simplify. So negative 7 squared is a positive 49. And then again, I like to see this as one product. So a negative times a negative gives us a positive. And then we have 4 times 3, which is 12. 12 times 2 is 24. So then I'm going to just go ahead and add 49 plus 24, which gives me a sum of 73. So again, here we found a positive. It's positive, so therefore 2 real roots exist, so I continue. The time that I'm going to stop is when this discriminant is negative and there's nothing to solve for, and then I'll just stop and write no real roots exist. But because it's positive, we're going to continue. So step 2, let's plug it all in. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Sounds kind of creepy after a while, doesn't it? All right, so b, again, is a negative 7. And this is why I use parentheses, because often people will think that the negative in the formula represents, the negative in the formula will represent the negative in b, which it's not the case. So be careful with that. And then we already found what b squared minus 4ac already is, and that's a 73. And now a goes on the bottom, which is a negative 3. So we're going to simplify this a bit. Now, here's the thing, though. All right, so let's go ahead and simplify this first before I move on. So we get, so step 3, simplify. X equals a negative times a negative is a positive 7 plus or minus the square root of 73. Divide that by 2 times a negative 3, which is a negative 6. All right, and so I usually like to put that negative up top. So you would see that more often than so. But for right now, we'll just go ahead and just leave it as such. All right, because I don't like leaving this negative down here. All right. So let's go ahead and look at example C. Excuse me. All right, so again, I'm going to move my constant to the left side, so I get negative 2x squared plus x. Now, using my algebraic properties, I'm going to subtract 6. Excuse me. All right, so now that it's equal to 0, I'm going to go ahead and start with step 1. All right, so b is 1, a is a negative 2, and c is a negative 6. So 1 squared is 1, and there's 3 negatives, which makes this negative. 4 times 2 is 8. 8 times 6 is 48, which leaves me with a negative 47 as a discriminant. So this is where those special moments come into play, where if your discriminant is negative, then no real roots exist. So you stop because there's nothing to solve for. There are no x-intercepts. That's what that negative is telling you. Okay, so your answer in this case would simply be no real roots. All right, so let's go ahead and take a look at example D. All right, so in example D, why don't you pause and you can try this one on your own, and then you can check it. So step 1, b squared minus 4 times a times c. So b, a, c. 2 negatives, which make a positive, and you get 20. So you get 29. So we get x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now we're going to drop those in. B is a negative 3. A is, our discriminant is 29. Excuse me, and a is 1. So to step 3, simplify, you should have gotten 3 plus or minus the square root of 29 all over 2. And there you go. All right, so I will be assigning your practice on the quadratic formula all in all. So if you have questions that say, without solving, what are the nature of the roots? That's something that's asking you to just use the discriminant, the b squared minus 4ac. If it says solve the following equations using the quadratic formula, then you're going to do steps 1, 2, and 3, just like we just did together. All right, so I'll be posting your assignment from the textbook momentarily for this as well.